Welcome to the Slop Farm. Enjoy the video.
You start by verifying data and compute. Gather 10K to 100K labeled clips and confirm sample rates. Once done, partition into train/val/test sets and normalize audio to 16,000 Hz. Then you select a baseline model, small CNN or pre-trained transformer, and install required libraries: Python 3, 10, PyTorch or TensorFlow plus Librosa. Make a virtual environment and commit an initial data loader. This gives you reproducible inputs. Finally, run one quick epoch to ensure the pipeline works before heavy training. You perform augmentation next to improve robustness. Apply time stretch, pitch shift, and noise injection while keeping labels accurate. Once augmented, define training strategy. Use batch sizes between 32 and 128, a learning rate schedule, and early stopping. Make sure to save checkpoints each epoch so you can roll back. You monitor WER and CER as primary metrics, plus per speaker accuracy. Visualize loss and validation curves to diagnose overfitting. Then you iterate. Tweak architecture, regularization, or data balance until validation stabilizes. You finalize by optimizing for deployment. Quantize or prune the model, or apply knowledge distillation so inference fits target latency. Once optimized, wrap the model as a REST API or an Edge SDK. Stream audio in frames with 50 to 200 ms latency goals. Make sure to test on representative devices and real-world noise. If something fails, first verify spectrogram inputs, confirm sample rate, window size, and normalization. Inconsistent preprocessing between training and deployment causes most errors, so fix that immediately.
Thanks for watching. Consider subscribing if we helped you today.